Hey guys, I'm an engineer, and my team got a project from the mayor. The project is about a crash course. How can we reduce the damage that might result from a car or other vehicle striking a new bridge support? The mayor wants my team to design, test, and evaluate solutions to the problem. The mayor also assigned us to record how the motion of a vehicle depends on the sum of forces and mass to help inform other city leaders of the science behind the solution.
In this project, the technology of Newton's law, forces such as friction and acceleration of an object will be shown. Our team chose to reduce the damage by constructing the barriers on the road. We chose the water-filled barrier. The water-filled barriers are easily portable without water filled in. The barriers are less harmful to the car and the drivers than many other barriers, since the barriers are made of plastic and filled with water. The barriers will break, reducing the car's speed. And the polyethylene plastic comes with colors that are very eye-catching and can be easily recognized even from far distance. However, it can be very dangerous when there is not enough water inside the barrier because it is too less to slow down the car.
The water-filled barrier reduces the amount of damage as the water absorbs the amount of energy from the car. The water-filled barrier is formed by a plastic container filled by water. In our model, we use drinking yogurts and tapes to make barriers, and boxes and tapes to make a lamp. Also, we put quail eggs on the toy car to show how the water barrier can protect human or quail egg from forces.
Let's watch our experiment. What would happen to the quail egg when there's no water filled in the barriers? Oh, unfortunately, it cracked.
And what will happen when there is a water-filled barrier? The quail egg didn't crack.
Our model car was 0.2435 kg. Quail egg was 0.0056 kg. Our ramp was 0.0617 kg, and drinking yogurt was 0.128 kg.
So the distance between the front wheel of a car and the barriers is 52 cm. It takes the car 2 seconds to hit the barriers, making the speed to be 26 cm per second, or 0.26 meter per second. The acceleration of the car is 0.13 by second squared.
And this is the 4 trials we did, and the car eventually stopped. Comparing this experiment to Newton's first law, when the car crashed into the barrier, since the car contained more forces than the barrier, the car would keep moving, but it would slow down by the opposing force exerted by the barrier.
According to Newton's second law, the car will accelerate to the direction of the net force, but still the barrier will reduce the amount of force. The larger the mass of the moving object, the less readily it moves.
Due to Newton's third law of motion, the barrier would exert the same amount of force to the car, but the water will absorb some of the force.
So now let's talk about speed, velocity, acceleration, time, and distance. Distance was 0.52 meter and it took 2 seconds. Acceleration was 0.13 meter per second square. Speed was 0.26 meter per second, and net force was 31.7 Newton. Let's look at this picture. The arrow pointing downward because of the gravitational force acting on a car, and because of Newton's third law of motion, the car exerts a force on the ground too.
When the car is in motion, the short arrow represents the friction which goes opposite the direction of the car. However, the car exerts more force than the friction. The car moves to the direction of greater force.
When the car hits a barrier, the arrow direction to the car represents the force that the barrier exerts on the car with the same amount of force. However, the car exerts greater force on the barrier, although the car slowed down.
Let's look at the free body diagram. The net force of the car is 31.655 Newton, or 31.7 Newton. The free body diagram shows that the car exerts more force than the barrier did. However, due to Newton's strength of motion, the car stopped because the barrier exerted the same amount of force that the car applied to it.
Solution for this problem is to construct a water-filled barrier on the road, near the bridge and the place where the most incidents happen. However, the administrator needs to weekly check the amount of water for safety. If the water lessens, it might be dangerous because the water is not enough to slow down the car. It's time to meet the mayor, so see you guys next time.